Let us consider this question. Solve del u over del x plus del u over del y is equal to 2x plus y u by method of separation of variable. This is a what? This is a PDE. How can we solve this PDE, partial differential equation? That is, when we have when a dependent variable depends on several or more than one independent variable, we call it a partial differential equation. So how can we now use PDE to solve this differential? How can we use this? How can we use separation of variable to solve this PDE? So let us consider this. Del u all over del x plus del u all over del y is equal to 2x plus y is equal to u. There are some steps that we have to consider in solving this. We cannot just go into it and solve this. So if you check on my previous lesson on separation of variable, I explained some steps taken or to be considered in solving this. We are going to assume that x and y is a what? We assume that u is a function of what? That is, u as a function of what? X and y. Then when we say u as a function of x and y, we will now assume that x is a function of that x, that is x is equal to x, or is a function of that x is a function of small x, and y is also a function of what? Small y. So our first step is what? Let's assume u is equal to what? Xy. That is, u give that u of what? X comma y is equal to xy. Where x is what? Where x is equal to s of x, and u, and y is what? Y of small letter y. That is capital letter Y of what? Of small letter y. So we now plug this. Whenever we see u, we plug it x and y. So let us now consider. We are going to have del. What's our u here? Xy all over what? Del x plus del u. What is my u? This is del or partial. What is my u? My u is what? Xy all over what? Del y is equal to what? 2x plus y is equal to u. What is my u? My u is what? Xy. So after this, I will now what? This thing is, I'm going to what? Differentiate this xy. Let me put it in brackets. I'm going to differentiate this xy with respect to what? The s. Del over the s. It means if I'm considering del of the s, if I differentiate partial all over partial s, it means I'm differentiating respect to x. Since our s is also a what? Our capital letter S is a what? Is a function of small letter s. It means if I differentiate x here, I'm going to have what? 1. If I multiply it by y, I'm going to have y. So I'm going to have y. Whenever I differentiate with respect using partial, that is, I differentiate a partial differential equation. This d will turn like this function, that is, this del over the s will turn as d all over that was I differentiating all over what? The x. If I let me come again, that is, if I differentiate this with respect to s, I'm going to have what? I'm going to have y. Then this del over the s or partial over partial s will change to what? What I'm differentiating with respect to all over x, plus if I differentiate this with respect to y, if I differentiate y here, I'm going to have what? 1 times s, I'm going to have x. So it will change. To change to del all over what? The y. So because I'm differentiating with respect to x, I'm going to have y. If I'm differentiating with respect to what? X, I'm going to have x. The partial will turn to what? D. That is, the partial differential equation will turn to what? ODE. That is, you turn to ordinary differential equation. So it's equal to what? 2s plus y. Then what is my xy? So my x and y. So the next step is to what? To divide through by xy. Let us divide through by xy. Divide through by xy. Through by xy. If I divide through by xy, I'm going to have y dx all over ds divided by xy, then plus s dy all over dy divided by what? Xy, then 2s plus y xy divided by xy. So what am I going to have? I'm going to have, it will be y dy ds all over dx times 1 over what? Xy divide return to what times plus x dy all over what dy times what 1 over what 1 over what xy then is equal to what is equal to 2x plus y all over what xy then xy. So here y will cancel. I'm going to have 1. So I'm going to have y dx all over dx. What is here? X. I can put it here. Plus s dy all over what? S will cancel. I'm going to have what? Y. So that's 1 over what? 1 over y dy. Then it's equal to what? S will cancel. Then y will cancel. If I open this bracket, I'm going to have 2s plus 2y. So in this one, I'm going to take 2s to here. Then I'm going to take 2y to here. That is, s will take x, y will take y. So I'm going to have 1 over s ds all over ds. Then minus 2x. And then plus 1 over y dy all over dy. Is equal to what? Minus what? Minus 2y. Minus 2y. My aims is to get x and y, to get the value for x and y. So it means I'm going to equate x as an what? As a particular constant k. I'm going to equate y as a particular constant k as well. So I'm going to have 1 over s dx all over dx minus 2s is equal to k. Then 1 over y dy all over dy minus 2y is equal to k. I can call this one equation 1. I can call this one equation 2. So from here, so let me take equation 1 over s, the s all over what? The small letter x, the capital letter s, ds, the capital letter s all over what? ds, minus, I can take this one to the equal to k plus 2x. So from here, I will now have what? If I open this one, I'm going to have dx all over k plus 2x. If I cross multiply, I'm going to have what? S ds. So since what am I going to do to separate the variable? I will take small letter s together. I will not take capital letter s together. So here is capital letter x. So it means this capital letter s will come here. For this capital letter s to come here, I will divide through by x. X then all over x. S will cancel. So I'm going to have what? The s all over x. I'm going to have the s all over x is equal to what? K plus 2s ds. So this is how to solve. These are the steps in solving PDE. Next is what? To integrate both sides. Then integrate. I'm going to have 1 all over s, the s is equal to k plus 2s ds. So if I integrate this, what am I going to have? I'm going to have ln x is equal to what? K. What is my k? If I integrate constant, I'm going to add it with the what? With that ds. If I'm integrating what? K as a constant, I'm going to have a ks plus, if I'm integrating 2s, I'm going to have 2s 1 plus 1 all over 2. Loss of integration. So I'm going to have ln s is equal to ks. 2 will cancel this. I'm going to have plus s squared plus what? This is what? Plus c plus constant c. So let's say our constant is what? C1. So I want to get value for s. So I have to eliminate this ln by taking exponential on both sides, taking exponential for both sides. So I'm going to have exponential ln s is equal to exponential ks plus exponential s squared plus exponential c1. So from here, this will cancel. I'm going to have x is equal to this one will turn to exponential ks dot exponential s squared dot exponential c1. So since c1 is a constant, I cannot just say s is equal to what? c1 exponential ks plus s squared as a constant. So it's common. So c1 exponential ks plus s squared. It means I've gotten my what? I've gotten x. So next is what? To find my y. Remember in equation 2. So my y will now be 1 dy all over dy all over what? Dy all over y dy is equal to what? K plus 2y. I've taken minus 2y to right hand side. So what am I going to do this one? To separate the constant, to separate the capital letter, I will take capital letter y to left hand side. I will take small letter y to right hand side. So it means since I'm having here, so I will just what? I'll just cross multiply. If I cross multiply, I'm going to have here from equation 2. I have 1 over y divided by dy minus 2y is equal to k. This thing means that I should have taken, since I'm considering k and I'm considering minus 2y this, I can take this one to here. So if I take that one, this one will be negative. I take it to right hand side from the beginning. So here I will have minus y. I'm going to have minus y plus 2k. This will be negative, this one will be plus. So this one will be negative and this one will be what? Negative. So if I now take plus to here, it will be minus 2y. So here I'm going to have minus 2y. So from I'm going to have minus dy all over what? Y dy is equal to what? K minus 2y. So if I cross multiply, what am I going to have? So I'm going to have minus dy is equal to k minus 2y y dy. So if I divide both sides by y, I'm going to have this. This will cancel. So I'm going to have 1 all over y dy is equal to what? K minus 2y dy. Then so I'm going to have 1 all over y dy then is equal to minus what? K minus 2y dy. So I'm going to have 1 all over y dy is equal to minus k plus 2y dy. So here can I say 1 all over y dy is equal to 2y plus k dy. Then I can now integrate. If I integrate, what am I going to have? I'm going to have 1 all over y is dy, then 2y plus k dy. So if I integrate with s, I'm going to have what? I'm going to have y is equal to, if I integrate 2y, I'm going to have 2y square all over 2, then plus ky plus constant 2. Since my constant 1 is c1, constant 2, so I'm going to have ln y is equal to, this will cancel, y square plus ky plus c2. So if I take the exponential of both sides, I'm going to have exponential of this, I'm going to have y is equal to exponential c2 y square plus ky. I can write like this, y square plus exponential ky. So here I can say s square should come first. If s square comes first, I can have s square plus what? Ks. Ks is still the same thing. So what am I going to do? We all know that our u is what? X and y. So it means I'm going to, what is my x already? My x is c1 exponential s square plus ks multiplied by what? Y as c2 exponential y square plus ky. So if I multiply this, what am I going to have? So minus 10, this is minus k, minus 10 minus, so it's minus k, this is minus k, this is minus k, we have minus k, minus ky, is minus ky, minus ky, minus ky. I have here is minus ky. So since this is a constant, this is a constant, I can say it should be a what? Constant term as c. U is equal to what? Maybe AB or general constant c exponential s square plus y square plus ks minus ky. So my u will now be c exponential s square plus y square. K is common between them, plus ks minus what? Y. K times ks plus 99 minus y. So is the what? Is the solution of the PDE, is the solution of the PDE. So you can say that we have done what? You can say that we have what? That is, we have use separation of variable to solve this. So it is the solution to the required PDE. So that's how to use separation of variable to solve a partial differential equation. I hope you find it interesting.